After the United States and Europe, the Japanese space agency JAXA is the third big player in government-controlled space science. Today we are investigating Hayabusa 2. In 2010, the Hayabusa space probe returned asteroid samples to Earth. Four years later, on December 3, 2014, the Japanese space agency JAXA launched Hayabusa 2. The second asteroid sample return mission is operated with an improved ion engine system and rendezvous the primitive carbonaceous asteroid 162173 Ryugu on June 27, 2018. Ryugu, the destination of Hayabusa 2, has an estimated mass of 450 million tons. "77 craters and over 4,400 boulders are spread over the 8.9 to 2.5 million years old surface. From an astronomical point of view, Ryugu is very young. According to JAXA scientists, Ryugu is a rubble pile with about 50% of its volume being empty space. Ryugu is a spinning top-shaped asteroid, similar to Bennu, which we will discover later in the season. Strong centrifugal forces shaped Ryugu and gives his western bulge a different shape compared to the rest of the asteroid. The western bulge is more structural intact, as other regions are more sensitive to structural failure. The border between the eastern and western bulge is called Tokoyu and Horai Fosse. C-type asteroids like Ryugu are too fragile to survive the entry into Earth's atmosphere. In the solar system, carbonaceous asteroids are expected to preserve the most pristine materials. These are mixtures of minerals, ice, and organic compounds that interact with each other. Scientists hope for new additional knowledge of the origin and evolution of the inner planets. The ion engine has 4 solar electric ion thrusters and uses microwaves to convert xenon into plasma ions. 3 engine generators parallel, thus accelerating the plasma ion by applying a voltage from the solar panels and eject it out the back of the engine. Other improved instruments are the guidance and navigation technology, antennas and attitude control systems. The probe communicates with 2 high-gain directional antennas for X and K band with data rates between 8 bits and 32 kilobits. Hayabusa 2 uses an optical navigation camera telescope, ONC-T, which is a telescopic framing camera with 7 colors. It works in synergy with the optical navigation camera wide field, ONC-W2, and with 2 star trackers. Other instruments are the near-infrared spectrometer NIRS-3 for spectrographic analysis, thermal infrared imager TIR, and the light detection and ranging LIDAR instrument to measure the distance from spacecraft to the asteroid surface with the laser rangefinders. Hayabusa 2 also carries 4 small rovers that investigated the asteroid surface to inform the environmental and geological context of the samples collected. The probe's weight is 610 kilograms and gets its electric power from bilateral solar arrays. Power is stored in 11 lithium-ion batteries. Compared to other asteroids of its kind, Ryugu has a surprisingly little number of water molecules on its surface. Asteroid pieces found on Earth contain more water molecules than found on Ryugu. Hayabusa 2 surveyed the asteroid from a distance of 20 kilometers for 1 year and a half. The probe carries the Mobile Asteroid Surface Scout MESCAT, lander of the German Aerospace Center DLR and the French Space Agency CNES. MESCAT carries an infrared spectrometer, micrometer, a magnetometer, MESMAG, a radiometer, MARA, and a camera, MESCAM, that imaged the small-scale structure, distribution, and texture of the regolith. MESMAG detected no magnetic field. MARA showed low thermal conductivity of Ryugu's boulders. MESCAM detected 2 different, almost black types of rock with little internal cohesion, but no dust was detected. MESCAT is capable of tumbling once to reposition itself to operate further measurements. MESCAT was deployed on October 3, 2018 and fell 55 meters down to the asteroid's surface. He operated successfully for about 16 hours as expected. On February 21, 2019, the first touchdown was operated to collect the first surface samples. On April 5, 2019, the probe released an impactor to create an artificial crater of about 10 meters in diameter on the asteroid's surface to get a subsurface sample. Two touchdowns in 2 different regions collected samples from the surface with the help of a kinetic penetrator that was shot into the asteroid's surface. Hayabusa 2 left Ryugu on November 13, 2019 with around 16 kilograms of surface samples and is expected to return to Earth in late 2020. The retained 30 kg of xenon propellant in the tanks of Hayabusa 2 can be used to extend the mission. On candidate for an extended mission is asteroid 2001 WR1. A flyby could be proceeded in June 2023. Hayabusa 2 will release the capsule with the surface samples which will re-enter Earth's atmosphere with a speed of 12 km per second. The capsule will deploy a radar reflective parachute and eject its heat shield at an altitude of about 10 kilometers. Then the capsule transmits a position signal. The capsule is planned to land at the Woomera test range in Australia.